Okay, let's start, everyone. So today I'm all ready because saya mau tebus balik kesalahan saya pada minggu lepas lah. Okay, I didn't realize that when we were doing this slide, that it was different than the exercise. So everything that you've done in the exercise is correct, and I want to thank Wilson for pointing out that one of the exercise questions is actually in the textbook. Okay, and so I studied the textbook after that, and then I realized, oh, okay, di sini pula rupanya saya salah. Okay, so if you already have detected my mistake, okay, from last week's video, just bear with me lah, okay, while I explain this to the rest. Okay, so the first thing we need to see is that this whole thing over here, in these two experiments that you can see over here, okay, the most important thing is that actually the voltage is the same. Okay, so even if, okay, so this is arranged in series, only two batteries lah. Okay, two batteries arranged in series, whereas this one is four batteries. So two over here and two over here. So there are four batteries, but they are both arranged in parallel. Okay, so each of the two batteries are arranged in parallel. So that means whatever happens, the voltage, okay, in this one is 3 volts, and the voltage in this one is 3 volts. So when the amount of the voltage is the same, okay, we find that, of course, the internal resistance will affect the amount of current lah. Okay, and that's why this reading happens, because the amount of voltage is the same. So the only thing that we take into factor, benda yang hanya memberi pengaruh adalah dia punya rintangan dalam berkesan. Sorry, the internal resistance. Okay, the internal resistance will affect the amount of current that flows out of the battery. Okay, and that's why we say that in a series circuit, we find that, oh, okay, the current is slightly less than in a parallel circuit. Okay, because in the series circuit, the resistance, the internal resistance is higher. Okay, and so that makes this particular part, okay, this makes this particular part a lot more logical lah. Okay, in a series circuit, okay, so in a series circuit, this one you have 4 batteries and all of them are arranged in series. So your EMF will be increased. Okay, when you have a higher EMF, you will have a higher current over here because the amount of energy that you have, atau if you think about battery as like a water tank lah, the amount of water in your tank, okay, is a lot. Manakala, if you're arranging 4 batteries, okay, all together like this in parallel, okay, you find that the EMF is the same as if it is just one battery. And that's why in this case, the current will be lesser. Okay, so there's a slight difference, there's a slight difference between this situation and the situation we saw just now over here. In these two situations, the amount of EMF is the same. Okay, and that's why the effects of it, now we can see that, oh, okay, if the EMF is the same, if the amount of voltage from the two batteries is the same, okay, then we can say that only the internal resistance will affect the current flow. Okay, how much current comes out of the battery lah. But in this particular diagram, you will find that the EMF is different. Ini adalah 4 bateri. Okay, 4 bateri memang membekalkan lebih banyak tenaga jika dibandingkan dengan satu bateri. Okay, this one walaupun dia disusun secara selari, even though it is arranged in parallel, okay, the EMF that you provide is only the same as just one battery. It's just that, let's say battery ini kehabisan cas sudah. Okay, this battery can still work. Then this one finish, this battery can still work. This one finish, this battery can still work. But they still only provide one battery's worth of EMF. And that's why in a series circuit like this, the current flow is still less because it's as if one battery saja mengalir. This one is all 4 batteries together work and boost the current flow. Okay, because there's a lot of energy over here. Okay, so that's the main difference lah. Therefore, when we talk about this question, and this is where I made the mistake last week lah. Okay, read this question, yeah. Okay, so in this question now, we find that the number of batteries are all the same. 3 batteries, 3 batteries, 3 batteries. It is just that they are arranged differently. Okay, so this situation is not the same as the one in the activity, but it is more same as the one in the table. Okay, and so we find that when we calculate the total resistance, we have to take into account this 9 ohms as well. Okay, which was, I believe, something that Lester did last week. And then after I said, no, Lester, you shouldn't take it. Okay, so that is my mistake. Okay, but we find that in this case, okay, the current flow in A is 0.375 amps. Okay, in B, when you arrange the 3 batteries in parallel, the question you should ask is it going to be more or less or the same as 0.375? And so we find that the answer will be significantly less. The current flow will be significantly less, although the internal resistance is less. Okay, although the internal resistance is less, but the problem here now is that they are not providing the same amount of EMF, okay, as provided in this situation. Okay, so this is the dangerous thing. Look at the EMF value. In situation A, the EMF is 4.5. This battery plus this battery plus this battery. But in this situation, the EMF is only 1.5 because only one. Okay, only one flows. Now, the third situation is a combined situation. So we find that in this one, the internal resistance is 0.5. Okay, but this plus this together, the internal resistance together is 1.5 ohms. Okay, so take a look at the internal resistance. This one, the first situation is 3. Second situation is 0.33. The third situation is 1.5 amps. And so we find that the current that is flowing, okay, will be less than the one in series, but it's definitely more than the one in parallel. Okay, and take a look at the EMF. The EMF is 3 because over here the EMF is only 1.5. Okay, manakala di sini adalah also 1.5 lah. Remember that when batteries are arranged in parallel, they have a choice. Current has a choice. One to flow through here atau one to flow through here. They cannot. Okay, fine. Sorry, I'm not supposed to say it like that lah. Okay, actually, what happens is, in reality, what actually happens is that when current flows over here, bila dia sampai kepada simpang ini bahkan, it's going to split into 2 equal parts. Okay, and then the split into 2 equal parts means that over here we'll have a little bit of 1.5 and here a little bit, sebahagian daripada 1.5 lah. Tapi bila mereka dua ini digabung, it is as if only one battery is working, 1.5 volts. Okay, that is the reality lah. But you can think of it in this situation lah. You can think of it as bila arus sampai di sini kan, dia akan memilih mana satu jalan yang dia mau pilih. Kan macam webinar tadi lah, kau boleh buat satu table untuk membandingkan, lepas tu cari isteri. Okay, tapi in this case, it is as if the current flow, as if the electrons have a choice. You want to flow through this battery or you want to flow through this battery. Okay, in reality, it's not, but you can think of it this way lah. So because of that, because they only have one choice, means that the current can only flow through 1.5 volts. It cannot flow through the other one. So di sini 1.5 volts, di sini no choice lah. Memang mesti melalui this battery. So 1.5 volts. That's why the that's why the EMF, inilah sebabnya kenapa EMF untuk ini adalah 3 volts. Okay, this one is current has a choice lah, can go here, can go here, can go here. Tapi dia hanya boleh pilih satu jalan sahaja. So bila dia memilih satu jalan, it can only have 1.5 volts of EMF. Okay, so in that respect, we find that the current flow for the series circuit is the highest. Although tadi kita cakap current flow for the series circuit is lower than this one. Okay, but that is a different situation. That is a situation where the EMF is the same. But in this case, the EMF plays a role as well. Okay, and this is the more important one lah. Tolong, I think it's better to consider this one compared to the activity that we saw just now. Consider internal resistance and also the amount of EMF provided. The more energy you supply, obviously you're going to have a better current flow. Okay, that's very logical. You learned this since Form 4. Okay, more energy means, the ball fly faster lah, things like that lah. Okay, when you hit the ball with a lot of energy, the ball can fly faster. Okay, when you hit the ball with very little energy, then okay, that's very logical. We think of it in that kind of logic. The bigger your EMF, the bigger your current flow. And that follows Ohm's law. Okay? So when we calculate this situation, we need to take into account lah. Okay, macam mana itu bateri disusun. Okay, so saya harap saya sudah menebus menebus saya punya kesilapan daripada minggu lepas. Okay, yang memang susah untuk diampunkan lah. Okay, saya sangat mohon maaf. Okay, so sorry, in this case, this one will give a greater current. Okay, dia berbeza daripada yang kita tengok tadi itu. But this one is in terms of the calculation. That's why in question number 5, we see two identical bulbs A and B are connected. EMF of each dry cell is 1.5. Which bulb lights up brighter? If you know this situation from just now, you know that this one will have a bigger EMF. Bigger EMF means bigger current flow. Okay, and that's why in the first situation, the effective resistance is 0.5, 0.5, 1.0 ohms. Okay, because it is arranged in series. Then when we calculate the I, we get, astaga, we don't need the R lah, okay, actually. Okay, we find that over here, okay, the EMF is 3 volts. Okay, in this case, it's also 3 volts because of the way it is arranged. Okay? Yeah, because of the way it is arranged. Okay, but since the resistance is arranged differently, okay, we find that the current in this circuit is bigger. Okay, the current in this circuit is bigger because the effective resistance is smaller. This is a case of, look guys, this is a case of same EMF. Okay, sorry, my mistake over here. This is the same EMF. 3 volts, this is also 3 volts. Okay, when we this one. And so because of that, we find that this current is bigger because the effective resistance is smaller. Question number 4 and number 5 are entirely different altogether. Okay, question number 4 and number 5. Oh, okay, sorry. Question number 4 and number 5. Question number 4 is about different values of EMF. Okay, this one, three batteries still give you 3 volts. This one, 3 batteries gives you 4.5 volts. Question number 5 is, one uses 2 batteries, one uses 3 batteries. Yeah, sorry, my mistake. This one only used 2 batteries. This one used 3 batteries. But in this case, the EMF is the same. Both also, the EMF is 3 volts. So when you have a situation where the EMF is the same, the only thing you need to consider is the internal resistance. Okay, whichever has the lower internal resistance will have the higher current flow. Okay, so this is maybe a slight problem that you have to consider. Like, kau kena pikir, you have to think about both situations. Okay, whoever has a bigger EMF naturally will have the bigger current flow, but okay, you also have to consider the internal resistance. Okay, so in this respect, we cannot just simply make an assumption without the calculation. Okay, the calculation for this is actually quite important. Okay, we must take that into account. So because the current flow is in circuit 2 is larger, walaupun kita tidak tahu berapa nilai R, we don't know what is the resistance of this menthol. Okay, doesn't matter. But when we calculate it, we find that, oh, okay, the internal resistance is lower. Okay, in the second circuit. So the current in circuit 2 is larger, so the bulb in circuit 2 lights up brighter. Okay. Okay, question number 6 is the same as the one in your textbook. So I'm going to skip this. If you cannot understand what is going on in the textbook, Wilson, is this the one in the textbook? Can you double check for me? Is this the one? So yang 4.5 mana dapat for question 4? This is the one. Okay, question 4. Let me go back to question 4. Mana 4.5? Oh, astaga, Nina. 4.5, this one. Because this is 4.5, because this is 3 batteries. Hold on, let me erase. So ugly. Okay. Okay. So Elijah, your question is, how do you get the 4.5 for the EMF, right? I hope that you're asking this one. Because it is 3 batteries. 3 batteries is 1.5 plus 1.5 plus 1.5 all together. because the current flow must flow through all three batteries. So that's why you get 1.5, 1.5, 1.5. Coming back to the question number 6 now. Question number 6 is the same as what Wilson just said just now. Is textbook page 121. Okay, so I think you can go through this yourself, but essentially, since these are two batteries in series and these are two batteries in parallel, okay, you kind of know where this is going lah. The circuit one will have a greater current because this one has a greater EMF. Okay, 1.5 plus 1.5. Ini current can only pick one only. Dia boleh naik atas atau turun bawah. Dia tidak boleh ambil dua-dua. So the EMF is only 1.5. Okay, so in this respect, but sorry, at the same time, also notice that the effective resistance also plays a part. Okay, this one has a bigger EMF but a bigger effective resistance. This one has a smaller EMF but a smaller effective resistance. Okay, so when we calculate it, okay, we find that, oh, okay, if you take a look at this, it is as if the current is directly proportional to the EMF and the current is inversely proportional to the effective resistance. Smaller the effective resistance, the smaller the effective resistance, the bigger the current. Yeah. Okay. But, okay, kau tengok big effective resistance, tapi big current pula. Kan? Small effective resistance, small current. Okay, so we cannot just say ini adalah betul atau ini adalah betul. We have to qualify it by doing the calculation. Okay, we cannot just simply say, oh, okay, because this is a bigger EMF, therefore the current is bigger. We have to consider the internal resistance as well. If one of it is the same, okay, if let's say one of it is the same, katakan in both cases, the EMF is the same, then kamu fikir pasal internal resistance saja. Or if in both cases, the internal resistance is the same, then kamu cakap pasal EMF saja. But in both cases, if the EMF and the internal resistance is different, you have no choice. And this this question number 6 is a prime example of that. Okay, kalau kita cakap, oh, semakin besar internal resistance, semakin kecil the current. Okay, then this doesn't make sense because this has a bigger internal resistance but a smaller current, a bigger current. So we cannot say that. So if you can write this in your module, okay, when you are talking about the current flow that involves the effective resistance, internal resistance, and also the EMF, you must take into account both factors. Kedua-dua faktor memainkan peranan, especially kalau kedua-dua adalah berlainan. If the internal resistance is constant, then you only think about EMF. Okay, kalau internal resistance-nya sama, EMF saja mainkan peranan. Kalau EMF-nya sama, then the internal resistance is the one that determines the size of the current. But if both of them are different, like in this question, both the EMF is different, both the internal resistance is different, you cannot make any conclusion melainkan dengan membuat pengiraan. You have to calculate it, okay, by using the formula that we learned. Okay, so be careful because in terms of difficulty, okay, I find that whenever I teach electricity, this is the most difficult subtopic for a lot of students because they cannot wrap their heads around the fact that sometimes there are more than one factor that affects things. There are two factors. Okay, so in my experience, this is a difficult subtopic because banyaknya mau ingat. Okay, but if you think about it logically, actually very logical one. Okay, everything in physics is very logical. Okay, actually it's very logical. Okay, all right. Is this question also inside the textbook? Yeah, this question is also inside the textbook, but in this case, take a look. Okay, we find that when we compare the current in the arrangement of the 2 dry cells in parallel and 3 dry cells in parallel, mana ini? Okay, 3 dry cells in parallel. So if we 3 dry cells in parallel, we find that the internal the EMF is the same. EMF is the same, right? Yeah, the EMF is the same as the 2 each one. Okay, EMF is the same, but now the internal resistance is different. Okay, and so we find that the current for the 3 dry cells arranged in parallel, 3 dry cells, okay, the current is bigger. Ini adalah 0.1475, yang tadi adalah 0.146. Very small difference lah, because internal resistance is very small. Okay, but there is still a difference. 0.1475 is still different than 0.146. Okay, so in this case, this question is dia bercakap tentang EMF-nya sama, tapi internal resistance-nya berlainan. Okay, and we can then make that conclusion lah. The bigger the internal resistance, the smaller the current. Okay, and that's why this number 3, increasing the number of dry cells that are arranged in parallel will increase the current in the circuit because the effective internal resistance decrease. Dengan syarat that the EMF is the same. Okay, with the condition that the EMF is the same. Okay, so to summarize, we need to think about EMF, okay, current flow, which is the letter I, and internal resistance. Okay, internal resistance. Okay, as so EMF affects the current, and the internal resistance will also affect the current flow. So different arrangement of batteries, different amount of batteries will change these two factors considerably. Okay, if you have 2 batteries in series, 3 batteries in series, okay, it is different than if you have 2 batteries in parallel, 3 batteries in parallel. Okay, so ada banyak situasi yang mungkin berlaku, okay, in this one lah. Okay, so which means that we have to really sit down and take a look at the circuit and think. Okay, calculate lah. Especially if both of these values are different. Okay, you have to do calculation. You cannot make a one sentence conclusion just because one is higher than the other. Okay, ada 2 faktor yang menyumbang kepada pengaliran arus okay, bila kita pertimbangkan susunan bateri. Okay, dan juga the internal resistance and the EMF. Alright, let's do these questions. Okay, tutorial 7.4, what is electromotive force? You know what, can you just take a look at the name list and you all answer alphabetically lah, okay? Ken, is that okay? I would like to start with the letter J. J for Jacinta, and then J, K, L, M, N. Yeah, did you think that I'm going to start at Adam again? Kesian Adam, kan selalu dia first. No, today we're going to start with the letter J. Cause J for July. Okay, Jacinta, question number 1.
D.
D, the answer is D, the work done by a source of energy in driving 1 coulomb of charge in a complete circuit. Okay, it's a very long and honestly, it's a very nonsense definition now. No, not nonsense because it's not true. It is true, but it's so panjang that it's like, kalau kamu menghafal this definition kan, kamu sudah masuk ke dalam God mode lah. Okay, even I don't memorize this definition. Okay, number 2, next person. Which circuit can use to determine the electromotive force of a battery?
C.
Why C, Christia?
Sebab dia punya voltmeter tu atas bateri.
Very good, sebab dia punya voltmeter itu adalah pada bateri. Okay, definitely not the ammeter. Ini sesat. Ini sesat entah ke mana ini. Okay, ammeter and voltmeter. Ammeter must always be di cawangan utama. Okay, ini memang out lah. Okay, ammeter must always be in the mainstream. Okay, voltmeter is the one that is the different stream. So if C we use to determine the electromotive force, what about A? What about this one? This one is used for which experiment? Who can tell me?
Ohm's law.
Ohm's law, okay. A is the arrangement for Ohm's law where current and voltage, current and potential difference are directly proportional. Okay, so different placing kau tukar tempat ini voltmeter sahaja, terus kau tukar eksperimen sudah. Okay, the graph for question A, what kind of graph are we expecting? V against I. Somebody else besides Mordecai, please. Thank you for Mordecai for answering, but I want somebody else. Graph A, if we put the voltmeter over here, what kind of graph are we expecting?
Directly proportional.
Directly proportional. And what about this one? The EMF, if you place the voltmeter with the battery, what kind of graph are we expecting?
Decreasing linearly.
Decreasing linearly, okay? Decreasing linearly, the value of the y-intercept represents what?
EMF.
EMF. And the gradient?
Internal resistance.
Internal resistance. Okay, thank you. I think that's Lester, right? That really sounds like Lester. Okay, so but that doesn't mean that you're not supposed to answer the next question, Lester. Okay, number 4, number 3. Oh no, I've already answered this. Cannot. This one I already answered. This is D. Number 4. Okay, number 4, Lester. 3 resistors, yada yada. Which of the following statements is true?
B.
B. V1 is more than V2. Ooh, which of the following statements is true? How come it's so weird one? Actually, this should be B, this should be C, and this should be D. I don't know why this is here. Oh no. Okay, actually the answer is A. Okay, because guys, this is 2R and this 2R. So the effective resistance is 1 over 2R plus 1 over 2R equals to 2 over 2R, so equals to 1 over R. Therefore, when we flip this one, is the same resistance as this. The internal resistor, the resistor for this and the resistance for this is the same. So since the resistance is the same, the current flow will be the same over here and over here. Okay, A1 will be equals to A2. Okay, astaga, I tell you what, this question why did Lester say V1 is more than V2? The resistance is the same. Okay, when you calculate the total resistance, the resistance is the same, so the voltage flow is also the same. Okay, fine. Thank you, Louis. But I think question 5, there's something missing there. Sorry. Okay, question number 6. Next person.
My answer is B.
Your answer is B. Why? Why B?
Yep. 0.2 divided by 0.2.
0.2 divided by 0.2. Okay, so you calculate the EMF is given. You calculate the voltage drop. Okay, the voltage drop will be 0.2. Okay, then you divide with the current. Okay, 0.2. Because as I said, the single most important thing whenever we're talking about EMF is the current flow is the same throughout. Okay, in the same circuit different circuits, different current but in the same circuit, the current flow is the same. Whether it's going through the battery or going through the resistor, internal resistance, external resistance, current flow is the same. All right, good. Number 7.
A.
A. Okay, A. Okay, how do you get A?
9 divided by 3.
9 divided by 3. Okay, 9 divided by 3 will be 3 amps. Okay, I'm not sure which method you're using. If you're using the method that I taught in the video, which is the V drop method, okay, which I personally think is much easier, you will get the same answer. If you use the formula as given in the textbook and in this module, you will also get the same answer. All right, good job, Michelle. Number 8. It's number 8 now. Okay, fine. What happens when F decreases? F? I cannot tahan this now. When I decreases, it should be I. This should be I.
Decreases.
The what?
The voltage.
Okay, the voltage decreases. Try not to use the words voltage. Dia diterima lah sebenarnya. But if you're looking to up your game, if you want to make your answer sound more intelligent, like if the examiner see, then wow, this is an A+ student, use the words potential difference. Okay, really makes you sound a lot smarter. And it's the same thing lah, voltage potential difference sama saja. Okay, macam kamu panggil Melanie and Melon, it's the same person. Okay, just one sounds nice and one sounds weird. All right, number 2, determine the value of the potential difference when the current is 0.0 amps. Show on the graph how you determine V. Next person.
1.5.
Okay, how do you get 1.5?
Sambung dia garis.
Okay, sambung the garis. Sambung the garis, guys. Sambung the garis. Okay. the word for English lah, in English is called extrapolate. Okay, bila kita sambung garis, and I just want to mention that when you sambung garis, you should actually sambung dengan garis putus-putus. You shouldn't have a solid line like this. Okay, these are all answering techniques lah. Okay, so sambung dengan garis putus-putus and you will reach 1.5. Okay, and because I was so focused on asking Shafiq Iqbal, how do you show on the graph, I forgot to ask him 1.5 what? Okay, 1.5 durians, 1.5 chickens, 1.5 volts. Okay, never forget the unit. All right, name the physical quantity that is represented by this. This 1.5 volts represents what value? Next person, Shim Kali. Oh, really?
Current.
Nope. 1.5. Voltage when there is no current is called what?
EMF.
Okay, it's called EMF, electromotive force. Okay, be very careful. This is a very commonly asked trap question because people will see, oh, okay, 这个是voltage, therefore is voltage. No, guys, voltage or potential difference when there is no current, okay, is called electromotive force. Because when there is no current flow, the voltage yang ada itu kan, yang kamu baca, is the amount of energy inside the dry cell, inside the battery. Okay, it's called EMF. All right. Next, internal resistance. Can somebody give? Sorry, the next person who is next after Shim is whoever.
Me.
Okay, me. Thank you, me. Can you please answer B?
Zero. I'm not sure, but is it 0.58?
0.58 what?
Ohm.
Okay, 0.58 ohm. First of all, when you calculate gradient, hold on. First of all, when you calculate gradient, you obviously need a triangle. Okay, when you do after you do the triangle, this is the answer that they got though. Negative 0.48. Number one, it must be negative. Because the line is negative gradient. Okay, R equals to negative M. So after you get this negative 0.48, which is the gradient, you will get the internal resistance R equals to M. R equals to 0.48. Who answered that just now? Is Tian the only one that got 0.58? All of you also got 0.58.
Wrong.
Sorry?
I got 0.5.
You got 0.5. How about the rest?
0.5.
0.5. Tian, do you know where you went wrong? How come you got 0.58 is a bit higher?
I think I'm wrong because 我用错那个 I used wrong the 0.875. Yeah.
Zero. Yeah. You use here. Here. This 0.875.
Yes.
Hold on, let me see. I think it's kind of impossible. Oh, can lah, 0.87, 0.5, 0.6, 0.7. Cannot lah. How you can see 0.875 over here, right? It's a bit ridiculous lah. Can you guys see 0.875? Even if I use my special magnifying glass that I buy from Timbuktu also, I don't think I can see the 0.875. I would probably use this point lah. Okay, so this is 0.9 minus the highest point, so 1.5. Okay, over and then this one will be 1.2 or 1.3? 1.2. 1.22. Oh my goodness, 1.22 minus 0. How much would that be? 0.9 minus 1.5 divided by 1.22. 0.49 would be my answer. Okay, 0.49. Of course, it's ohms lah. But guys, seriously, don't worry. This is just exercise only, okay? In the real exam, the graph is very huge and very sure you can see one. The only way you cannot see is if you're blind. Okay, but this is just as practice. The most important thing is we calculate the internal resistance from the graph by calculating the gradient. Okay, that skill is more important. you know that, oh, okay, if I'm given a graph, internal resistance is the gradient. This one you must know. Okay, because counting gradient is something that you've been learning since Form 3. Okay, so don't worry about the skill, worry about the facta. Okay, the facts is more important. C1, from the graph, show the value of V when I equals to 0.8. Next person.
I think it's 1.1 V.
1.1 volts.
Well,
Okay, so according to this, obviously we do this lah. Okay, obviously the thing that we have to do is to draw this. Now, if you are extending a line, this is called extrapolation. Okay, if you are finding a value, okay, this is called interpolation. Okay, I don't know why, kenapa saya mesti tulis di atas perkataan yang sedia adalah. Saya kena ruang ini. Okay, so this is called interpolation. And according to this module, the answer is about 1.1 volts lah. Okay, I know that it is a little bit difficult to see. So if you answered 1.15 or 1.2, I think, sorry, 1.15 or 1.2, I don't think it's a big deal lah. Okay, just make sure that the skill of doing interpolation is there. Okay, finding the value inside the graph yang sudah sedia ada is interpolation. Extending the graph is called extrapolation. That's why namanya pun extra. Okay, sebab kamu tambah garis yang extra. Okay, C2, the resistance E is given by R, yada yada. Calculate the value of R when I equals to 0.8. And since I'm done with W, Adam, you are this next.
1.375.
Okay, 1.375 ohms. Okay, this is a simple calculation lah. You already got the value 1.1 from C1, and then you just divide by 0.8. Whatever value you got over here, itulah value yang kamu pakai. Okay, just make sure that it is correct. Okay, kalau kamu dapat, okay, if you got 1.5 over here, definitely that's wrong lah. So 1.5 is here, but okay, 1.1, 1.2, no, 1.2 cannot, 1.1, 1.15, 1.12, maybe I can accept. All right, question number 9. Next person, the EMF of the cell, yada yada. Calculate the reading of the M-meter only when switch S1 is on. Kalau ini adalah on, ini off, okay, calculate the reading of this M-meter. Eliska?
0.3A.
Okay, 0.3A. Actually, the answer is 0.33. Okay, kalau boleh use 2 or 3 tempat perpuluhan lah. Okay, 0.3. Good. Number 2, both switches S1 and S2 are on. Dua-dua sudah on. That means this becomes a parallel circuit. Okay, calculate the reading of the M-meter, please.
Is it 0.44?
Okay, 0.44. How do we do this? Is first you have to calculate the total resistance. This is a subtopic, the previous subtopic punya question. Calculate the total resistance. Okay, and then you get R equals to 3.53. And then after that, you use V equals to IR plus R. Okay, the 1.0 ohms, just like you did with question number 1. Okay, and then after that, you will get the value of the current. If you are using the V drop method, okay, then it will be the E is 2.0. Okay, and then the voltage reading is, astaga, dia tidak bagi tahu pula kan. Oh yeah, then you have to use IR plus R. Yeah, okay, sorry. Next question. Do we need to do this? Should I do this? Hold on. Current flow in circuit for 1 hour. Okay, you know what? I will give you the answer for this lah. So, this is a very common current. This one, and if you have power banks, like okay, standard power banks nowadays lah, the standard power banks is at least 10,000. Okay, mAh. Okay, I want to ask you a question, and this one I want an answer from you lah. Okay, tomorrow you give me the answer. Go and find out how to read this mAh. Is it milli? What is it? Milliwatt? Okay, I really cannot tahan when the salesperson especially kalau contohnya sampai kedai kan, wah, you see this power bank is 10,000 mAh. Yeah, I'm like, what is mAh? Okay, no, you don't want 10,000. No, it's 50,000 mAh. What is mAh? Okay, please, okay, for the love of God, learn how to read this correctly. Okay, it's not ma. Ma is how you call your own mother. Okay, ma begitu. But this is not how we read this unit. Okay, kalau MA is milliampere, but MAH is slightly different. Jangan juga, okay, this one saya pernah tanya ni. And then some people, you know what they say? Oh, ini bah, kalau orang Sabah kan, kami cakap milliampere. Begini. Sebab dia suka tambah H di belakang. Milliampere. Begitu. Please, it's not. Okay, it is not pronounced that way. Go and find out what this MAH means. And then next time you go to the shop, and then if somebody sell you the power bank, right, you can correct that person and say, bro, don't say ma. Okay, ma is how I call my mother. Pergi, go and research. How do you read how do you read this MAH? Okay, so the next time you buy power bank, you can like tunjuk lagak lah. Okay, battery labeled with 1.5V, 500 mAh. Okay, 4 same batteries are arranged in series and then in parallel. So let's talk about if the internal resistance of the battery is 1 ohm, let's talk about the current flow in the circuit for 1 hour. Okay, hi everyone. I want to first explain what does this mean, okay, 1.5 volts and 500 mAh. So basically what it actually means is that this battery, okay, the battery that is provided has a potential difference of 1.5 volts, and it is able to produce a current of 500 milliamps for every hour. That means in 1 hour, the 1.5 volts can produce a current, okay, of 500 milliamps per hour. Okay, and that's why in the circuit flow, okay, in the circuit flow in this table, it says circuit flow in the current flow in the circuit for 1 hour. Okay, in the series arrangement, we find that it really is 500 milliamps. Although there is 4 batteries, okay, and they are arranged in series, it is true the potential difference is big. Okay, but the current that comes out after the four batteries is still the same. Okay, 500 milliamps, because there's only one outlet, hanya ada satu jalan keluar saja. Okay, manakala in the parallel circuit, since every battery, every dry cell is able to produce 500 milliamps of current, okay, and since there are 4, so in 1 hour, all 4 will produce a current of 500 milliamps, and that's why the current flow is 500 times 4. Okay, in that 1 hour, it is able to produce 2000 milliamps. Okay, now in order for us to understand this one, so I took a look at the another article. I went to search online, and I saw this very interesting article, which I think I should share with you all. Okay, so this one, voltage and current produced by batteries in series. So in series, so if two 1.4 batteries are connected head to tail, the total voltage is 3 volts. Okay, so that makes sense. So this is because batteries in series produce a voltage that is equal to the number of batteries. So the batteries in series will bertambah when you sambung lah. Okay, now so a 9-volt battery will produce a voltage that is 6 times larger, okay, than a single 1.5 volt battery. That's normal. But the current in the circuit will be the same. Okay, whether it is 1.5 volts or whether it's 9 volts, okay, if the label on the battery says 500 milliamps, okay, for example, like one just now, the current produced is still the same, no matter how many batteries you put in. Okay, this happens because the batteries are arranged in a line, like water flowing through different hoses connected in a line. So if you have a lot of hose, and every hose is like one battery, and if you sambung all the hoses, the fact of the matter remains is that there is only one tempat untuk masuk and one tempat untuk keluar. So what goes in one end must come out the other. Kalau 500 milliamps yang masuk, in the rest also will be 500 milliamps. Okay, dia seperti passing parcel lah. Okay, correct. 1.5 volts. If let's say you have 4 batteries arranged in series, there's a lot of voltage there. But the current is just being passed from one battery to another. Okay, macam passing parcel. So the amount of current that it is passing is still 500 milliamps. Okay, sebab it is carrying the same current. But in parallel, okay, so when batteries are placed in parallel, all the positive terminals are joined together, blah, 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 okay, like this. Now, remember the voltage increases when batteries are arranged in series, but in parallel, that's not the case. And we've established this much earlier. When two or more batteries are placed in parallel, the voltage in the circuit is the same as each individual battery. Okay, we've already talked about this. So even if you have 2, 3, 4, or 10 or batteries, the voltage will still be 1.5 volts because they are arranged in series. The voltage doesn't bertambah, okay, in a parallel circuit. But in a parallel circuit, individual electrons can only pass through one of the alternative paths and batteries at a time. Means that when the current flows through here, it can only choose one way to go. Okay, thus, each electron can only gain energy from one of the batteries in the circuit. Okay, as the voltage is a measure of the energy carried by the electrons in the circuit, the increase in voltage for each electron in the circuit is the same as if they had passed through only one battery. Okay, but the purpose of batteries in parallel, okay, take a look at this. When batteries are connected in parallel, the current flowing through the circuit increases, okay, with the number of batteries in the circuit. Okay, each battery can pump a set of number of electrons per second for a given circuit. So if 2 or more batteries are connected in parallel, the number of electrons they can produce, okay, is added. Hence, the total current in the circuit is increased. So to summarize, when batteries are connected in series, the voltage increases. But when batteries are connected in parallel, the voltage remains the same as 1. Okay, but the current that can flow in the circuit increases because there's many ways for the same amount of electrons to come out. Manakala in series circuit kan, as I said lah, it's like a hose. You join all 4 hoses together, the amount of current that goes in is the same amount of current that goes out. It just gets passed from one to another. Okay, but in parallel, it's okay, masuk sini lah, masuk sini, masuk sini. So, you know, they can go in here, they can go in here, they can go in here, and they can come out at the same time. Okay, they can come out at the same time. So, you know, there's a lot of current that is flowing lah. Okay, there's a lot of current that is able to flow. So coming back to our question just now, okay, that's why in this case, we find that the current flow in the circuit is only 500 milliamps because in series circuit, the voltage increases, but the current remains the same, as if there's only one battery. In parallel circuit, the current increases, okay, with more, dia macam terbalik daripada series lah, okay, but the potential difference is seperti hanya ada satu sahaja. Okay, but the potential difference, okay, since it is in series, it will be combined. 1.5 plus 1.5 plus 1.5 plus 1.5. Okay, but the potential difference will be 1.5 if it is in parallel. There's only one of, it is as if only one of the batteries is actually functioning. Effective internal resistance for series will be very big. Okay, be 1 plus 1 plus 1 plus 1 because the internal resistance for each battery is 1. For parallel, it'll be 1 over 1 plus 1 over 1 plus 1. It'll be 0.25 ohms lah. Okay, there'll be less. There will be less effective total resistance. Okay, so 6 volts 500 milliamp bulb is set up between A and B. So if we put a bulb over here, okay, which has 6 volts and 500 milliamps, explain what will happen to the bulb. Okay, in the series circuit, the bulb will light up in the parallel with normal brightness, okay, for about 1 hour. Okay, but in a parallel circuit, the bulb will not terpasang because there is not enough potential difference to light up the bulb even though the current is high. Look at the current flow. Current flow is high, but the potential difference is so tiny, and then bergabung lagi dengan the internal resistance, okay, there will not be enough potential difference. Okay, already the EMF is 1.5. Okay, and because of the internal resistance, there'll be less than 1.5 volts coming out. Okay, this one needs 6 volts. Okay, a 6 volt 500 milliamp bulb means that you need to provide it 6 volts in order for it to function fully. Okay, so a 6 volt 500 milliamp bulb is set up between A and B for each circuit. So in the parallel circuit, okay, we find that the bulbs, not to say will lights off, like the bulb will not even turn on, okay, because there is not enough potential difference. And when you think about that, okay, so another one I need to mention is, why is it that this one, the bulb that is 6 volt 500 milliamps, this one lights up, and then this one, okay, in parallel it doesn't. Okay, so I forgot to mention just now that this is actually a condition. Ini adalah syarat. Kalau kamu mau, if you want the bulb to light up, kalau kamu mau bulb itu untuk menyala, it has to be given 6 volts and it has to have 500 milliamps of current flowing through it, minimum. Okay, so in this case, in the case in series, we have 500 milliamps, no problem. Okay, and we have provided 6 volts of potential difference. So they akan light up with normal brightness for 1 hour lah. Okay, because we're talking about 1 hour. But in the case of the parallel, we have more than enough current. Okay, we have 2000 milliamps of current, but our potential difference is so tiny. Okay, 1.5 volts. So kita tidak memenuhi syarat yang diminta oleh the mentor. Mentor said at least 506 volts, then I will light up. So if you don't fulfill this request, and because we are arranging this in parallel, so this is, this one tidak boleh lah. Okay, that's why we say here the bulbs will light off because there's not enough potential difference to light up the bulb even though the current is high. All right, last question. Can we have, who is the next person? Who was the last person I called? Oh, Brandon. Brandon is next. Total EMF that is supplied by the dry cells arrangement for diagram 1 and diagram 2. What is the total EMF?
Diagram 1 tu teacher, satu.
Okay.
And diagram 2 0.5.
Kau jawab, kejap, kau jawab yang mana satu ni? Kau jawab EMF kau jawab internal resistance?
EMF.
Why would it be 1 though?
Salah. Diagram 1 EMF dia 3. Diagram 2 EMF dia 3 juga, sama.
Okay. The EMF, thank you. The EMF will be the same. EMF-nya sama kalau kedua-dua, because in this one dia memang 3 volt lah, 1.5 plus 1.5. But in this one, the EMF will be current can only choose 1. So whatever happens, the EMF will be gabungan of these two. This will also be 3 volts. And just now the answer that Damir gave was actually the answer for the internal resistance. Internal resistance for diagram 1 will be 1 ohm because every single battery is 0.5 ohms. So 0.5 plus 0.5 will give you 1. In diagram 2, because they are arranged in parallel, okay, you will get every one will be 1. Every set this set is 1 ohms, okay, but because they are arranged in parallel, okay, you will actually get 1 over 1 plus 1 over 1 equals to 2, okay, which 1 over 2 will give you 0.5. Okay, so this one, the total resistance, okay, the effective resistance is 0.5. Now, remember the situation we talked about at the starting of the class. The EMF is the same, okay, the internal resistance is different. Okay, this one anybody can do. So I'm going to call the people that didn't do the question just now. Wilson, compare the voltmeter reading V1, V2, please.
The voltmeter reading in V2 is greater than V1.
Okay, why? Okay, hi everyone again. So I want to explain this why is it that V2 is bigger than V1? Okay, so I'm going to refer to diagram 1 and diagram 2. The one thing we know, okay, about both the diagrams okay, is that in diagram 1, the EMF is 3 volts. Okay, EMF is when the switch is off. Okay, when the switch is open, okay, or the switch is off, then the reading of the voltage will give you the EMF. So in this case, it's 3 volts because 1.5 battery plus 1.5 battery. Okay, in this case, it is the EMF is also 3 volts. Okay, this one kita sudah jawab tadi lah. Okay, but the problem happens when the switch is on. Okay, bila switch ditutup, okay, when the switch is on, okay, the voltmeter reading doesn't show you the reading of the EMF anymore. It shows you the reading of the voltage in the entire circuit. Okay, and so, okay, let's talk about this. In diagram 1, okay, in diagram 1, change to blue color lah. Okay, so we know that the EMF is 3 volts. Okay, the internal resistance is 1 ohm. And we do not know what is the resistance of this menthol lah. Okay, I'm just going to call this resistance the big R. Okay, now when you think about this, okay, as I said just now lah, since we don't know what is the current, okay, we have to probably use the formula. Okay, so in this case, it will be E equals to IR plus I small r. Okay, and I know that my E is 3. Okay, and my IR or the voltage, the voltage. So this IR actually represents V1. Okay, plus I times 1. Because in the diagram 1, the internal resistance, when you total it together, will be 1 ohm. Okay, therefore, I can say that V1 is equals to 3 minus 1I. Okay. Now, when we look at diagram 2, the only difference between diagram 1 and diagram 2 is the internal resistance of the battery. Okay, I'm going to use black for this now. So in diagram 2, you will find that E equals to V plus IR. Okay, of course, I can say this as V2 lah. Okay, V2, we're not interested, again, as I said, we're not interested in how much current is flowing now. Okay, but we just want to see the connection between this V2 and V1. Okay, and since in the second diagram, the internal resistance is 0.5. Therefore, I can say that my E is still 3 lah. 3 equals to V2 plus 0.5I. So if I rearrange this, I'll get V2 equals to 3 minus 0.5I. So now you compare this and you compare this. 3 minus 1 and 3 minus 0.5. Who will have a bigger voltage? Obviously, it will be V2 is more than V1. Okay, this has to be, this is the mathematical proof lah. Okay, if you want me to really explain it to you, it is simply put, okay, simply put, this has lower internal resistance. Okay, so there is going to be a bigger voltage that is flowing in, no, there's a bigger voltage that is available for the circuit to flow. Okay, that's the short version, but this is the mathematical proof for why V2 is more than V1. Okay, the ammeter reading A1 and A2. Can I have, who else haven't I called? I want to call Oswald, but I don't know whether Oswald is here. Can I have either Brandon or Daniel? Ammeter and the brightness of the bulb. So diagram 2 is bigger than diagram 1. Current flow. Okay, according to this, yeah, it's correct. Okay, because the effective resistance of diagram 2 is smaller and the EMF is the same. Okay, which is what we were talking about just now lah. All right, brightness of the bulb. Since A2 is bigger than A1, come on, this is the last one. Who will have a bigger brightness? M1 or M2?
M2.
M2. Okay, thank you for answering. M2 is bigger than M1. Okay, so once again, I think probably the biggest confusion here is why is the voltmeter reading different? Okay, the voltmeter reading is different because don't forget that when you turn on the switch, okay, when you turn on the switch, the reading of the voltmeter is no longer showing the value of the EMF. Okay, the reading of the voltmeter is no longer showing the value of the EMF, but it is actually showing the voltage that is running across the circuit. And since there is a bigger current flowing across the circuit, there will be a bigger voltage. Okay, because the resistance is less.